This video is covering solving inequalities and finding intercepts. When you are working with an inequality, you have an equation. However, it's not an equal sign, it's a less than, greater than, or less than or equal to, or greater than or equal to sign. So the basic steps that we used to solve equations are still going to apply. And when solving inequalities, just like equations, it is legal to add or subtract the same number to both sides of the equation or to the inequality. So let's do a couple examples completing those steps. So on this inequality, we have x minus 5 is greater than 20. Our goal is to get x by itself. So we're going to add 5 to both sides. Cancels out, and x now is greater than 25. So any value greater than 25 would satisfy and make this inequality true. To complete number 2, we have x plus 7 is greater than 37. Let's subtract 7 on both sides. And x is greater than or equal to 30. So as long as x is greater than or equal to 30, it would satisfy this inequality. On number 3, we are adding a negative 4. And so the opposite of a negative 4 is plus 4. And so we're going to add 4 to both sides. Cancels. X is now less than negative 7, and 4 would leave us with a value of negative 3. Next, if we have multiplication or division when we're solving an inequality. When solving inequalities, just like equations, it is legal to multiply or divide by the same number to both sides of the inequality. In the investigating inequalities activity, we saw, though, if we're going to multiply or divide both sides of the inequality with a positive number, we are going to keep the inequality sign the same. If you multiply or divide both sides of an inequality by a negative number, you must flip the inequality sign to maintain a true statement. So let's do a couple examples like that. So I have x divided by negative 8 is greater than or equal to 4. We need to get x by itself. So the opposite of divide is multiply. So we're going to multiply both sides by a negative 8. And as soon as you write down that you're multiplying by a negative, I recommend flipping your sign so you don't forget. Now 4 times negative 4 times negative 8 is negative 32. So for this to be true, x must be smaller than or equal to negative 32. On this next problem, x divided by 6, the opposite of divide by 6 is multiply. Multiplying both sides by 6. 6 is positive, where inequality sign is going to stay facing the same direction, so x is less than 18. On number 6 here, we have 5 times x is greater than negative 15. The opposite of multiplying by 5 is divide. Divide both sides by 5. X is now greater than negative 15 divided by 5 is negative 3. Now I moved a positive 5. I am not going to flip the sign. So now that we've done a few problems like that, let's do just some general solving. So these would be two-step solving inequalities. So I want to get x by itself, so I'm going to subtract 14 on both sides. I have 2x is greater than or equal to 8 minus 14, which would be negative 6. And I'm going to divide both sides by 2. Now I'm dividing by a positive 2. My inequality sign is going to stay the same. On number 8, here's an example of variables on both sides. This is a 1x over here on the left. I'm going to subtract 1x from both sides to get started. 3 minus 1 is 2x. I'm going to add this 2 to the other side. 2x is greater than 3, and I'm going to divide both sides by 2. Again, I'm dividing by a positive. I'm going to keep my sign the same. I'm going to leave my answer 3/2. If you'd like, some of you are going to type that in your calculator and get 1.5. I'm going to just go ahead and leave that as a fraction. Moving on to example number 9. Again, I'm trying to get x by itself, so I know I need to get rid of the 4 and the 9. Order of operations in reverse. I'm going to subtract 9 from both sides. And 7 minus 9 is -2. Oops, kind of looks like a 4 there. So I have x over 4. I'm going to multiply both sides by 4. Now x, again, this 4 is positive, so I'm left with 4 times -2, which is -8. And now when we have inequalities, we need to be conscientious of rewriting so that the x is on the right side, excuse me, the left side. And so I'm going to rewrite this so that the x is on the opposite side. And so I need to pay attention. When I read this backwards, it says x is bigger than -8. So I need to write that just as so. So x is greater than -8. So this is rewriting, that is not flipping the sign. So on example 10 here, let's go ahead and combine like terms. So 3x and 6x combine and make 9x. So we have our -2 is less than or equal to 7. I'm going to add 2 to both sides. So I have 9x is less than or equal to 9. Divide both sides by 9, and x is less than or equal to 1. So at this time, go ahead and try both, or hit pause and try examples 11 through 14. Here are the equation inequalities that you have attempted to solve. On number 11, you needed to distribute and get -4x minus 12 is greater than 8. And continue to get x by itself by adding 12 to both sides and then dividing both sides by -4. Because you divided by a negative, you needed to flip the inequality sign. On number 12, it's a one-step equation. You're dividing both sides by 6. 6 is positive, so you're not flipping the sign. And the last two examples here, on example 13, you are subtracting the same. I chose to subtract x first from both sides. Continuing through, and the very last step, I had to divide by a negative, so I had to flip this sign. You may have chose to do this work in a different order, but you still should have ended up with x is less than -1. On 14, the first step is to combine like terms. 6 and -10 combine to be -4x. Once I combine like terms, I add 8 to both sides. And then on the last step, I divided both sides by -4. So again, I flipped the sign to have x is greater than 1.